recording.
All right.
For the
So what do
record,
you do now?
yeah, for the record, I ended up not reading this chapter, unfortunately, because
Sure.
uh,
You would
Lemon's
love part of
last
it.
his last week was crazy. Mine was just tiring in the sense of I was recovering from a minor crunch that I had at the beginning of the month, and it threw off my sleeping schedule, which messed up everything else. So
Sure.
Mm.
Well, I think like that's a little bit unfortunate because you will not remember anything that I want to ask about what's happening here. Uh,
Maybe I can remember some things
yeah, maybe he
on
can
this.
remember, and maybe Marin you can get along throughout the way. So something that is really cool is the fact that he's making the internal mechanism to develop variables immutable, like
Mm-hmm.
straight up. It's not like an advanced improvement. It is straight up vanilla immutable, and that's great. Uh,
yeah, because so far, whenever you pass a value somewhere, he's basically copying the value, right?
yeah, he's gonna talk about the copying. It's fine. He's gonna talk about the copying a little
Oh,
bit later.
oh, actually, he can't pass values anywhere because he doesn't have names for them.
Yeah, he does. No, that's what we're gonna do.
Mm-hmm.
That's the purpose of this chapter, is to add names. Add labels. I should be pedantic about that. He called it naming values, but he's very explicit that this is basically labeling.
Mm-hmm.
Basically.
Labeling those structures that we built on the other section.
Yeah, not only no, not only about structures, but naming things, naming values. So if you have a number
All right.
one and you want to add a name that should be swapped with one, that's what we're gonna do. And
Okay.
of course, we're gonna use something called an environment, right?
Mm-hmm.
An environment. Um, so we actually, this reminded me a lot of our own thingy because we also did the same thing. So if you go to whatever evaluator, where is it? Oh, here. So
Uh,
eval-env, right? So we
This is
basically did the
pretty
exact
standard,
same
right?
thing. It's what?
But this
yeah,
is
this
this
is
is pretty standard, right?
it is pretty standard. Yeah.
Not
Uh,
really. He could have a mutable
Not really.
global environment and just never pass that around ever. But he's
but the environment
purposely
has to
passing
exist
it and
somewhere.
returning it every time.
Yeah, but the environment has to exist somewhere, whether it's mutable or not. Is a design decision. But you
Yeah.
kind of need to have an environment if you want to have names, right?
Oh,
Yeah, because
and
the environment's like a table to translate the names
another
for the
difference.
stuff they refer to, right?
Another
Yeah.
difference. He is actually overriding duplicates. We are throwing an error
Mhm.
in our version. We throw an error. Uh,
Oh, so Spatula doesn't allow name collisions.
yeah, it doesn't allow shadowing. Doesn't allow
No
shadowing.
shadowing.
No shadowing. First,
No
because
shadowing.
that we didn't discuss at the time, and second, because I don't like shadowing at all.
Uh,
Okay.
I like shadowing, but only in the context of here's a thing. It's convenient to be able to refer to it, but I don't want it to be publicly available.
Hmm. Okay. The reason I don't like is because if I'm reading a piece of code and I need to keep track of what this name in this particular line is at this moment in time, because it's not the same thing throughout the entire piece of code. It changed to something else. And of course, if you have smaller functions, this shouldn't be a problem. But anyway, I still have to figure out the best strategies to apply shadowing. So
Uh,
whoa,
there's a way to sidestep the problem. Just use a concatenative language. Then you don't have names for things.
just don't
So
have the
shadowing,
names.
yeah, so shadowing never comes up. That's
The
your
name of
problem
the
solved.
variables is going to be the full blown everything. So we don't have any limitations in naming things, which is cool. So this is
Basically
basically
full ASCII
defining the syntax.
almost. Well, no white spaces, but then white spaces are two separate symbols,
Yeah,
so
exactly. But you can have things. I think he even says this, that we are allowing things that are not usual to be allowed as labels. And
Yeah,
here is
in
the
C
definition.
and most other
For
languages
example,
usually only allow alphanumerics and underscores, right?
Yeah.
But Lisps traditionally have always been like, nah, just use whatever characters you want. We're cool.
Yeah. Okay, so this is basically
this will.
go.
Do you think this will include also symbols starting with numbers?
Symbols starting with numbers.
Yeah,
Yeah,
there's
That's a good
actually
question.
actually
I,
different
I
Lisps have different answers to that question.
Mm-hmm.
Racket, I think Common Lisp most. I'm not sure about the standard, but I would expect most implementations of Common Lisp um, to basically try to parse it as a number, and if that fails, treat it as a symbol.
Oh
Um,
wow, that's
in
unusual.
Clojure, symbols
fancy.
beginning with numbers are explicitly forbidden, but you can have numbers elsewhere, just not at the beginning.
Is that a GVM limitation?
Uh, I'm not sure. I don't think so.
Ah.
I think it was to avoid the problem of asking if this is a number or a symbol, like
Yeah, because
Okay.
the
while reading
problem is
code.
is to deciding if what the thing is. I mean,
Yes.
Yes,
The
yes.
cool thing about
Um,
this is that this is the entirety of the parsing process. It's done because it's already developed to the point that it is like you just need to add a line and done. That's cool. Uh,
what was added here?
he changed this line.
Ah, okay.
I think symbols are already there, so maybe that's why the parsing is so simple. So he's just changing the allowed um, characters to be
Mm-hmm.
symbols. But this is really nice.
Mm-hmm.
This is really really nice. Okay, then it comes the cursed part. This is very cursed. So we want to be able to refer, because now we don't have hard-coded things. Because before a plus was always the plus function, and a minus was always the minus function, and so on. And now we need to be able to diversify that, and the way that he did that is using function pointers. Function
I mean,
pointers.
that's kind of unavoidable because if you want to be able to evaluate arbitrary symbols, you're going to look them up in the environment, and if
Yes.
some of them are meant to be functions,
Yes.
you're kind of forced into function pointers.
But I was expecting void star, to be honest. I was expecting void star when I first.
Void star.
Yeah.
Why?
Uh, Void star would be useful if he wanted to have arbitrary, like, what can I say? If you wanted to have like,
Yeah, it would be for more generic programming in C. It's that's for the
yeah,
what the void star is for,
basically.
Yeah,
right?
but you are always returning that structure that we defined
Yeah, yeah, that's the thing.
previously.
I noticed that. Oh, this
So
is
you
always
don't need
this.
void star, right?
Yeah, so he can just use a built-in star, a built-in star. And there's a really nice section about how to read this
You
sort of
just
thing.
yeah, just re-educate me, please.
Okay, so he says, well, he first
Ooh.
starts talking about, hello, Mageta.
Hello, Mageta, welcome.
He
Oh,
first
Hello,
starts
Mageta.
talking about that there's a lot of, there is a convention on how to read the star. And the way that it should read this thing is to get an L-val star, we dereference L built-in, and we call it with these arguments. So let
What?
me repeat that. Let me repeat that. To get one of these,
This is the return type.
yes, to get one of these,
Yes.
you dereference this and apply these arguments to it. That's how you do it. That's what
And what the
this is.
type def does.
The type def does. The type def allows you to. I think
It's
it's
basically
creating
a type
this type
synonym.
alias, right?
Yeah, it's
It's
an alias.
basically creating this as a type alias. Um,
What?
yeah. So type def in C, struct in C.
by the
Um,
way, my Lisp is working
and
Oh, nice.
in what in
in
which
.NET.
sense?
Congrats.
In which sense?
In .NET.
Oh,
I
in
I can
.NET, the
I can
easy
write
easy compiling.
yeah, easy compiling. Yes, I can compile to uh, .NET, and then I can already define functions, variables. Oh, sorry, variables are broken. I'm working on that.
Yeah, that's what we are
Uh,
talking about actually. This
Ifs
is
and
what this
others.
chapter is about.
That's
Variables.
cool.
So this is how the type def works, Eiju. So you basically, instead of
Yeah, but
having,
if you go back just a little bit, go up or just a little bit, you see there type def existing name alias name, which it will be the new name, right?
yes.
But you see, this is so confusing for me in C every time because you see that it doesn't look that you have two things here.
It doesn't look that you have two things here.
Yeah. So what's happening?
Uh,
I have to.
I think it's because you want to be able to use this label, L built-in. That's why.
This is a new thing.
Yeah, this is a new thing that you can reference now.
Okay. So
Uh,
let's go.
okay, so
And
again,
We
go, Marinho, go.
will understand
If
better from the code.
he has terrible syntax for function pointers.
Yeah, but let's be honest. If you're not doing like real, like a programming job in the industry, you would never see this, man. Who uses this? I only know because of the Void Star because I watched some YouTube videos. But like, look at this. Anyway,
Yeah.
then it
Yeah, but
comes
I'm
this
not any specialist.
the type dependency because we want to add an L built-in to our L-val struct declaration. You want to add that. But how are you gonna define one first and the
This
other if one is asking for the other and so on and so forth?
sorry if I may ask, but I wasn't following the book. So this L built-in is like a plus, right? It's a
Yeah.
built-in
So that's the
function,
thing.
I assume.
In the until the previous chapter, all the symbols they had
Mm-hmm.
hard-coded meaning. So the plus was always the plus function, and the minus was always a function.
Yeah,
Now we
I
are
see.
defining variables, and we are allowing symbols as plus to be a variable.
Mm-hmm.
Then that means that we need to be able to control what the heck we're going to have in the environment. And the
Yeah.
way that you're going to
So
do that is
the
using this.
way I did, and it might be wrong, that's what I'm curious about. Uh, I see the length there, right?
Yeah, this is the
So
environment.
I did the same way we would evaluate. In my case, I'm emitting opcode, right? But I'm just setting a marker. And right now I ignored variables completely. I just
Mm-hmm.
had arguments for calling functions, right? So I push like a thing called argument that has just an
Ah.
index on assembly. But
Mm-hmm.
Oh.
to
Wow.
declare a variable, I'm just using atoms and then searching on the environment. But it's totally on memory. You see, so
Mm-hmm.
uh, I would need to store these symbols. Sorry, a reference for these symbols that I stored on assembly,
Yeah.
uh, with some label,
Yeah,
like
but only if you want
something
to
like that.
interpret, right? If you're already
Sorry.
compiling, yeah, if you're already compiling because you're using the assembly trick.
Is this book, by the way, compiling as well, or
Not
is it
no,
just
not until now. Not until
No,
now. It's not
this
compiling.
is it's no, it's never
It's
compiling.
an
it's
interpreter.
just
It's an
It's
interpreter,
just
interpreter.
an
right?
interpreter.
But Lemos, you kind of do need this kind of stuff even if you're compiling because you can call eval at runtime.
Yeah.
Are you
Oh,
are
and
you doing that, Magetta?
yes, I am.
Oh
Actually, I
wow.
do. I can evaluate and run things like a new definition, and I can also expand macros.
Oh, so your Lisp already has macros as well.
No, it doesn't have macros. I can just expand code because the parser is very minimal, right? It's
Of
very
course it is. It's Magetta.
yeah, and it's I'm using actually Yak and Lex.
Oh, okay,
So it's
the
Mm-hmm.
like
parser generator.
yeah, I can show later, but
Sure.
it's very minimal, and then I expand the code like the
Mhm.
forms, right?
Mhm. Okay, that's cool.
Very interesting.
Okay, then let's go back to the cyclic dependency problem. So you need to be able, again, what's the problem? This, we want to define this, but this asks for a definition of leval. But leval is not
Mm-hmm.
defined because leval needs to have an L built-in within. So the way that he solved that is to declare first the things. So he's
Mm-hmm.
first declaring the leval, not defining it, not just
The
declaring.
existence of Elval, yeah.
Exactly. And then he defines the built-in, and then there's a built-in inside the L-val. That's how
It
he
just
does it.
says
And this is the type alias thingy, the type def. That so you can use L built-in as a name.
L built-in.
Yeah, look, this is
So
this
L
name.
built-in means that function, a function
Pointer, a
that
function pointer.
Oh, sorry. Yeah. A pointer to a function
Yes. That receives two
that,
things.
that receives those two things
Yes.
and returns the
Yes.
lval
Yes.
pointer in return.
Yes. Exactly. So
Holy
that
shit.
so that is that. Then we
Don't you
need
love
to
Haskell when you see these things?
then we need to add some boilerplate code such as like how to create a
Oh,
function
yes.
pointer. So we did this to
Sure.
all of them. So like every single abstraction has one of these. We need to add to the enum and we need to add to the printing. And of course, as
Mm-hmm.
always, we're not gonna print functions because that's a little weird.
Yeah, just print
Uh,
function, right?
I
Yeah,
don't know,
just
man. You're doing a Lisp. Why not?
I
print the
mean,
body of
in
the function.
Dwarf,
You mean?
in
Yeah,
Dwarf,
What's
it's
the
not
meaning
so
why
of
not?
that?
strange
But well,
to
yeah,
print the body of a function because,
yeah, you
like,
can print the code. Yes.
That's fair. You have the
the
symbols. You
only
can just throw it out.
problem, yeah, the only problem is um, you are making more things observable within the language about how functions are implemented behind the scenes. So you may want
Yeah.
to pay attention to that.
Yeah.
Mm.
Maybe you don't want to show that. I have no idea. Then it comes the copying part. So remember, this is immutable, right? So every single time we have something and we do something with it, we have to discard the previous version of that. So he creates this function that we're gonna use later called copy. Um, but
Which
to
copy is the thing?
yeah, which copies a thing. But in the case of lists, which I think is the Q expressions, we need to actually iterate throughout all the things
Oh, yes.
and copy those as well.
Recursively, right?
Yeah, not recursively because this is C, so it's using a for loop. Um, oh, this is
But it is
recursive.
recursive.
This is
Yeah,
recursive.
but of course it should be
Yeah,
recursive, right?
it's nested. Yeah, it's nested. Sorry.
All right.
Okay, and that's pretty much it for the copying. So again, we just create a new thing because we're gonna basically do a deep copy, right? This is deep copy. Um,
Mm-hmm.
we create something out of thin air, and then we put the thing on the thing, and then we do a switch case to see which case it is, and so on and so forth. Then it comes the environment definition, right? So what the heck is an environment? The environment is a hash map, a poor man's version of a hash map, because you're gonna
Uh,
basically do a two arrays that's gonna have the same length, and you're gonna iterate through
actually,
to the former and use the index of the former to access the second.
It's a very C
actually,
solution.
this is very
Very
similar to a
received thing.
structure called plist in traditional Lisps, which
P
is a pair
list,
of
How's
lists.
does it call? P list?
E list.
property list.
Yeah, yeah, because it's a pair of lists of the same length.
Yeah.
No, this is not the
And
same thing.
no, and the reason you do this
Oh,
is because when you're compiling, it's convenient to be able to dereference the like to see what's the position of the name and then only care about that position instead of having to dereference the name every
Are you
time.
sure it's
Uh,
property list?
uh,
Oh, this thing is something else. It's an
common list.
XML on OS X. This is nothing.
Foundation
Uh,
class. Wow, there's
oh,
this
No,
is
forget
Apple
about
stuff.
this.
Yeah, so this is
This is
Apple stuff.
Apple stuff. Yeah.
No, yeah, but we
no,
are familiar because we use this.
you wanna look at this actually.
Send me
Um,
please. Thank you very much. So it's ambiguous. There are property lists that is what it is.
Oh, okay.
Used for representing sequence of elements, but sometimes more useful to represent a kind of key to value mapping, right? Key to value mapping. But of course this is very inefficient, right? Because this is not using a tree, which means that searching is linear, which means that you're screwed.
Actually, this is not quite it, actually. There's p-lists, which in this case it's key values alternating. There's a-list, which is a list of pairs, where each pair is a key and a value.
Which is kind of
Um,
what we're doing in here.
no, what we're doing is a pair of lists, where one list contains only the keys and the other contains only the values. I thought the name for that was a p-list, but
Oh yeah,
apparently I'm
you're
wrong.
right, Okay. But there are
But
other
yeah, they're
types of
based.
lists that they do this.
Yeah, of course, when you do this in Lisp, traditional Lisps, you use linked list, obviously. Here he's using arrays, but the idea is the same. They have the same length. One of them has the names, the other has the values. When you want to look up a name, you can just do it once, and then if you need to refer to that same like association in the future, you can just cache the position that you found originally, and it will be the correct position.
No, yeah, I don't think he's exploiting that in this particular chapter, but you can do that. Anyway, so this is our environment, right? So the only thing I think we are missing from dynamic arrays is like the capacity, because we have the count. We should have capacity. He doesn't have capacity because memory is cheap, as always. Um and then we have two arrays, one of strings, the other ones of pointers of lvals. So again, we need to be able to create an environment out of nothing. That's what we're doing there. And then this is how you delete the environment after you finish the program.
Mhm,
After you
mhm,
finish the REPL, right? Cool.
Wait,
mhm.
so let me get this right.
Sure.
There's no way to just like grow an existing environment, if I'm reading this correctly.
I think that's a
But this
realloc operation that is gonna do down there.
it's so expensive. Why?
No, no, no. But it doesn't like. I understand it's expensive, but that's not the priority of this author. We already know that. We already discussed that.
I know, but it still bothers me.
Yeah, no, that's fine. That's fine. Okay, so here's the deal. You have an environment and you have a key and you want to find the value. And then you're gonna return that. So it's linear, and that's it. You don't have a tree. You don't have anything for again. No performance considerations. It's just
Concerns.
yeah
No,
concerns.
like the linear search is actually okay if you plan to use it for compilation because as I said, you only need to do the search once, then you can just remember the position
That's
and
but
that's
if you
constant.
remember, that's not what it's gonna happen.
Yeah, it's very sad. It's
If you
very sad.
remember. Okay, and then if you don't find anything, because if you find, you're gonna basically return out of here. If you don't find, that's basically an error. And how do you put things in such an environment, right? So it's basically doing if again linear, and then if you already found it, that means that it was already there. Then you're gonna just shadow it. So that means deleting the previous entry, copying the entry that you want to include, and putting that in the
Mhm.
correct position, and you're done.
He's searching for key, right?
Yeah, he's searching for the key here.
Okay, casing.
Yeah. And if you don't
Mhm.
go to this return, that means that the key, the affirmation key is not in the environment, which means that you need to add that up. So you need to do the count plus plus. This is the realloc that I mentioned before.
You got
No error
space. No
handling
space.
whatsoever in the allocation.
Oh yeah.
No, that's cool. Uh, uh, yeah,
Come
When the
on,
allocation
nobody needs
fails,
error handling.
whatever, we just give up,
yeah, we
even
just
blow
give
up
up.
and
Yeah, but to
die.
be fair, adding your handling to this type of things would be very um, it would be bad for educational purposes. It would be bad.
No, it wouldn't, because now you're teaching people to not handle errors
No,
when
you're not saying
allocating.
that. We are the ones that already did such a thing, so we know he's missing that. But a newcomer would never think of that, I think.
But, ah,
We
but
know that
when
he's
Yeah,
missing that.
I have mixed feelings about this error handling for newcomers, for complete noobs,
Yeah.
because they don't understand logic yet.
No, if
Most of the
you
time.
are reading until this point, you definitely understand logic to some degree. If you're reading to chapter 11, you definitely know some logic. You cannot escape from that. But for
Mm,
instance, this realloc can provide a null because who knows?
sure.
Uh,
so the problem I have is that you're
that's
teaching
funny.
a beginner to have bad habits and not handle errors.
Oh yeah, I
That's my
think you should
main
have an
issue.
observation down here, a note saying, "My friend, you should not do error handlings." There is, you should do it. Which is what I love about Haskell, being honest, because when we did, I didn't have to care because everything it was in a do notation, so who cares? Who cares? I didn't have to care about this sort of things. I did exact kind of like the same philosophy, but mine had error handling because of the sugar the sugar notation, right? With do notation. Anyway, so now it comes the part of variable evaluation, which is basically a lookup. So when you are evaluating and you identify that you have a symbol, remember before the symbols were fixed, so plus, minus, etc. Now you need to look up in the environment, which means that the original functions they need to have a prelude of sorts, which he's going to call a built-ins functions, which we also did, Mageta and I, Nathan, back in the day. So here's the deal, and remember to delete, right? So you have this value that you want to evaluate, um, and then
No, but this is
this is not a
quite
value.
interesting
This is the
because
symbol actually. Go on.
he'll be able to um, reuse names, right? Tipo, how can I say this? It's not reusing names, but redefining functions,
Oh yeah, that's a very common thing in Lisp
right?
languages.
Yeah, but he'll be able to do it here.
And it's spatial, right? So a function definition in the top of the file, you can redefine in the middle of the file, and everybody up below will use the newest definition.
Uh-huh.
I never do that because again, I don't like shadowing by nature, so I would never do that. But if you want, you can do that. So again, the value we already know it's a symbol, so we need to have the lookup, and because we already know it's a lookup, we can destroy the previous value because again it's immutable. Which
I
again,
mean,
I need to emphasize that this is vanilla implementation. Go on, Marin.
about redefining functions, sorta, because like, yeah, sure, we can rebind the names. That's true.
Yeah.
But we don't have lambda yet. We can't construct new functions. We can only
But
rename the
but
ones
we
that
No,
we
but there
already
aren't
have.
functions yet. We don't have
we will have
user-defined
it.
functions.
We will have it.
We will have it.
Yeah.
We just need the syntax at this point after this chapter, actually. We already have the built-ins, kind of. The built-in, like, the foundation of having user-defined functions, which I think it's the next chapter, actually. Anyway.
Yeah, go
So,
on.
okay, then we have the eval s expression.
Mhm.
So there is a also needs to change. Instead of checking for a symbol type, we want to ensure it is a function type.
Yeah, because before
Yes, yes,
we were selecting the function by looking at the symbol at the head of
yes,
the list
yes. This
and
if
doing the
here,
dispatch,
this is
yeah,
the
kind of
if.
statically. Now, let's see. Yeah, now we're going to just uniformly evaluate the entire list as we were doing before, but instead of checking if it's a symbol, we check if it's a function
Yeah,
because if it was a symbol, the evaluation of the head of the list would have looked it up in the environment, and now we have a function,
yeah,
basically.
exactly, pretty much. Um, yeah, so if this if doesn't explode, that means that we can actually just call the function, providing the environment and the value. Yeah, so this is basically just changing the symbol semantics to be function semantics. And now we have the built-ins, which is basically the prelude. So the plus, the minus, the multiplication, and the division. We're gonna make like wrappers on top of them, which is a really sad thing in my personal opinion because you cannot use partial application, which means that you have a lot of noise and boilerplate things going on. Because look, E A, like, oh man. Uh, I like if it was me, I would swap and put the symbol in the beginning and just then that's it. Like everything else is fine. Anyway, so he also mentions that this is not the only code that you need to change. You need to change everything else that was calling the built-in OP. You're gonna have to change to these things. So you're gonna have to check out the types, and we probably should see in the GitHub, use GitHub, the correct code. But let's continue here. So now, what you
He's
gonna do?
doing more built-ins.
Yeah, no, he's defining the built-ins. This he's defining the prelude.
Yeah, sure. He's redefining those things, right? If I understood.
Yeah, he is redefining because it was already there, and we now, until this point, we lost it because now you can have a variable called plus. And he's adding it back using, but now
But
using
now
the abstraction layer functions.
yeah, just remember me. We have to redefine those things because now every function has to receive in this environment.
No, we have to redefine it because before it was hard coded that certain symbols would do certain functionalities, and now
Mhm.
this whole thing can't be because symbols are they're not keywords anymore. They are can be anything. They can be functions, they can be values, they can be whatever. Uh,
They are treated as variables by the interpreter
yes,
instead of
yes,
being keywords.
exactly. So we need to be able to add the functionality back, and this is how you do it. So how do you add a built-in? Easy. You provide the environment, you provide the name of the built-in and the definition of the built-in, so the function pointer to the actual functionality. Then you do some, you do some transformations and you put that in the environment. You delete the copies again because this is immutable by design. And then we have a function that's going to execute every single time in the beginning of the main entry point, which is add a bunch of things for me, such as list functions, and add a bunch of mathematical functions for me as well. Which is also what we did when we did in Haskell. We did exactly this. But instead of add built-ins and passing the environment, we had like default environment, and that default environment already had the things. The final step is to call a function before you create the interactive prompt. So here's the full-blown pipeline. You create an environment, you populate the environment with the prelude, which again, this sort of interface is really nice because you basically have an easy way to swap the prelude. That's it.
Mhm.
Um, and he probably is going to use this. I don't know how far this is going to go, but let's suppose that we want to add file support to our language. You don't want to only interact in the REPL. If you want a file, that's easy because you're going to parse that, and that's going to be the environment that you're going to plug when going to the actual evaluator. So this can be swapped with something else. And then we do the same thing as before and the same thing. So we evaluate and then we print, delete, so on and so forth. Also print errors. And here's the example. And I think here I had a question. I don't know if Marinho will be able to answer because he didn't have the time to read this time. But let's start with the first one. So if you put plus, because we have a prelude, this is going to print function, which makes sense.
Yes.
If you have an eval of head, my understanding is that this is going to pick the head out of these tokens, let's say, because it's a Q expression, right? The curly braces. You're going to
Yes.
apply this eval, you're going to apply the head into this, and this is going to get you 5.
Yep.
Sure.
Mhm.
Yeah, I think until now I am understanding. So
The
it's the
same
same
thing.
thing. You're going to apply the eval into this, but this happens to be a
Selecting
symbol of a
plus.
function. So like you can have a list of functions. Can your
You
C
can.
do that?
I mean, this is a list of symbols technically,
Yeah,
but you
but
could actually have a list of proper functions instead of symbols. That's possible as well.
no, if you have the lambda abstraction, sure, but
Actually, you don't even need the lambda. You can just do open paren list plus minus whatever, and then you have a list of functions.
sure. I think this is where I got. Oh no, no, wait, I'm not confused yet. It's down there. So you are applying the same thing. So you're applying head to this list using the eval, and this will return a plus, and then you have a 10 and a 20, so this will return you 30. That's fine.
Yeah, so you have a list of symbols, you take the head, which is the symbol plus, you eval, which will dereference the plus in the environment and return the addition function, and then you add the two numbers because this is the top level. It's implicitly treated as an expression, so plus 10, 20 is 30, which
Mm-hmm.
is what we expect.
Yeah. Yeah. Then we're gonna, but this is not enough, right? Because this is still doesn't. This is only the foundation, like the mechanism to allow us to create variables, which we're gonna do right now.
Mhm.
Because you cannot have like a label and just use that instead of the
Yeah.
numbers. This is just to show that everything that was working before, it is still working, and
Yeah.
now we have better.
you still don't have anything new, right? You have
No, you
only
have
new
something new.
machinery
If you put
under
plus
the
instead of
hood.
an arrow, it's going to print function. That's an improvement for sure.
Right, but this is not enough to define a
Yeah,
new
that's not.
symbols.
Yeah, that's not enough. So then we're gonna
He
go
needs
to
he needs a
this.
new primitive.
Yeah,
It needs
not
a
an. Yeah,
define
he
or
needs a new
something.
primitive, which is the define. Yes.
Mhm.
There's an important thing that I should mention. Oh yeah, it's here. So we need a way to map a label to an expression, and that can be any sort of expression. But he doesn't want to evaluate that. So he doesn't want to, like, pick an x, and if you have a plus 1, 2, he doesn't want to do x to 3. He wants to do x to plus 1, 2. So we need something that allows us to hang and to hold up to the evaluation process. How we managed to do that before? Using the Q expression mechanism. And that's exactly what we're going to do. That's exactly what we're going to exploit. So we're going to put them in the curly braces. So this is going to be parsed as a Q expression. And we're going to use that to define our to do our defines, basically.
Oh, this is basically, I see, this is basically like Racket's define values. You pass a list of symbols and a list of values, and you assign each value to the corresponding symbol with the same position in the other list.
Yes.
Except we're using lists instead of multiple value returns because this particular list only returns one value in each call.
Yeah, exactly. So let's go. So this is going to be the built-in def. Again, we made built-ins before, so we're just making a new one.
It's a new primitive, yeah.
So again, sometimes we have error checking. Sometimes we do have error checking.
Oh, this is actually pretty nice. This define is not
Actually,
actually a special form. It's a first-class thing.
It's
I
a first
think,
class thing.
yeah,
When you see built-in, it's basically a first class thing.
that's cool.
Okay, so let me remember what the heck is happening here. So the first argument is symbol list. And we ensure all our elements of the first list are symbols. Oh, I remember. Because we actually going to allow you to define multiple labels at once. So
Yep.
if you have a define AB and one shoe, the A is going to be to 1 and the B is going to be to 2. Right. Right. So that's why we need, that's why we are checking if we only have symbols within the first list, right? Then we check if they have the same amount of pairs, like if we're gonna be able to make pairs out of these two lists, right? And I think the -1 is because we need to exclude the define, the word define, I think. And then we just do an assignment. We just go to the environment and say, put into the environment this label with this value. And that should be it. That should be it. Then we need to add that to our using our generic built-in function. We just say this is the environment, this is the keyword, and this is the functionality. And here's the example. And I think here is where I had a problem. Here is where I had a problem. So let's start. So if you do these things and you ask for x, because you define it here, it's going to be 100. The same thing with y, and you can do operations with that. That's cool. Again, you can actually define them in one single shot instead of doing multiple defines. So AB will be 5 and 6. Then it comes like you have one thing in here in the first list of the labels, and you have a single thing in here, and you have 4 things in here. You have 4 things in here, right? But look,
Oh, I think
it worked, and he basically mapped
because
this label to the entirety of this, but I didn't see in the code how that's happening, how this switch of behavior is happening, of like
there's no switch actually.
there's no
yeah, there is
switch.
no switching.
No, no
Yeah, go
literal
back into the
switch.
example.
No literal switch.
No. What I
Go
mean,
back to the examples, please.
yeah. So you define x to be
Why
100. Then you
yeah.
define y to be 200, in both cases, the name is inside of a list, right? Because we
Yeah.
can have multiple
Mhm.
things, but the values are actually in line in the
Yes,
def form. Below, when you do the def arg list, the a, b, x, y are inside of a list, which is a single value.
which is one thing,
No, yeah, no,
It's
but
one
that's the
thing.
which
thing.
is
You
a
have
unit.
1 to 4, and it worked, and
No,
you have
No,
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 2 to
you
2, and it
don't have one
works.
to four. No, no, no,
it's
no,
one
no,
to
no. You
one.
have 1 to 1. You have one name to one list, and this list for this specific case has 4 things inside, but it's one list.
Ah, okay, that's that. Marinho, is that what you were about to say?
Yes, essentially.
So these are 2 things, and this is 1 thing.
Yes.
I see. Then okay, then it makes sense that when you ask for arg list, you're gonna have the single thing, and then he does arg list, and then 1, 2, 3, 4. First question: why there
Mm.
isn't curly braces in here?
Because he's actually evaluating the arg list and getting the list of symbols
Yes.
A, B, X, Y. And that's
Which
what we're
has
finding
4,
the
5
define.
things.
Oh, okay, so he's doing a lookup in here, grabbing
Yes.
this, and then evaluating
Yes.
A, B, C, X, Y to 1, 2, 3, 4.
Yes.
Yeah.
I'm dumb. That makes
Exactly.
sense. Then,
Yeah. I
uh,
I I I am curious to see what happens if you give them more or less names
no, it's
or
gonna happen. We
things
can see
to
here.
define.
We can see here.
It, it's gonna throw an error, right?
Yeah,
Because
if you have, yeah, it's gonna break in here.
What?
Yeah,
Check correct number of symbols and values.
yeah. If this fails, if this check assert fails, it's gonna throw this zero
Mm-hmm.
at your in your face. And I think in that part sucks because it doesn't tell you
Ah,
which one
okay.
of the lists are wrong. Which one is wrong?
Oh,
but
We don't
yes.
know.
you can't know which is wrong because
Yeah.
you have two lists of different lengths, right?
Yeah.
Essentially.
How
You
do you
don't know
know
I
which
which
would
one
one
has
always
is
the
put
right?
the wrong one as the one with more elements.
Why?
why.
That's just a convention, but for me it makes more sense.
What? Convention from your head.
Yeah, if I have 3 variables and 4 values, I'm gonna say that you have an extra value. That's my error message.
What if you have 4 variables and 3 values?
If you have this, then I'm
Yeah.
gonna say it's always the greater. It's always the one with the greater length, right? That's my convention. So if you have 4 variables and 3 values, I'm gonna say the greatest length, the one with the greatest length is wrong.
Okay.
Seems really reasonable to me.
It's also completely arbitrary.
Oh yes, but for me
Yes.
it sounds reasonable.
Yes. Okay,
Uh,
so let's proceed.
and the funny thing is that this is not this is it for for variables. But he went and said, our errors kind of suck, if you ask me. Then what about having a more powerful mechanism to report errors? Then he exploits the printf magic because if you ever read the source code of printf, you're gonna see that it uses the 3 dots.
Oh, I hate this tree does.
It uses the 3 dots, which basically means it's a variadic. Like you don't, it can be multiple things, right?
Mm-hmm.
Um, I was not. I never used it myself. I read the source code of printf, but I never used it
Mm.
myself. But I didn't know you had to use libraries because that's what you're gonna do. He's gonna use a standard library functions in order to handle the 3 dots. He doesn't tell us what that magic is happening with this library, but it does some magic. So if you have va list, va start, vsn printf, and so on and so forth, and he doesn't even tell you didn't even tell us which library is that one.
It's
But
in the standard library, right?
but apparently he does. Well, if it is the standard library, he should have mentioned that.
But he does mention it. Then inside the
Yeah.
function, there are standard
There are
library functions.
standard
No, no,
library
no.
functions.
Yeah, no. Standard library functions from stdio, from stdlibc, from stdint.
There is
Which
all. No, come on. The C standard library is one thing. There are many implementations, but it's one single thing.
Oh,
It's one
okay.
single
So
specification.
it is a standard library in specification, but we don't know the implementation. Fine.
Yeah, there are many
Uh,
implementations out there actually.
this function, okay, but again, he's just telling us that he's gonna use these VA auxiliary functions to handle the variadic part of the thing, which for me
Hmm.
it's still magic because he just does this, and apparently he just need to pass the last argument that has a
That's
label.
it. I don't remember exactly how these three dots work exactly, but it's not that magic because you kind of have a pointer to the thing, and it is standardized how
Oh
this
yeah, no, I
pointer
imagine that
should
this is
work.
interacting with a pointer of the memory or the
Yes,
stack, which
exactly,
has the arguments.
exactly.
Yeah, that makes
Do
sense.
you remember argc and argv? It's pretty much the same thing.
Yeah, yeah, yeah. But argv, it is written in the function argument, right? And it is a pointer. Where is
Yeah,
that? Where? Like, I'm pretty sure we can check the implementation later, but I'm pretty sure this is basically looking into the stack to see the argument stack. That's fine.
yeah, exactly. That you have a pointer to somewhere in the stack and just go from
Um,
there.
okay, then we need to, in order to use vsnprintf function, we need to allocate it first, but we don't know which size it's gonna be. So it's gonna basically put a 512 characters big as default, and cross his fingers that's gonna be enough, basically.
That's
That's
so irresponsible.
Huh?
that's
What?
so irresponsible. That's what Mario said. but we if you only provide 25, we're gonna realloc and give you back the memory. How nice? Hmm? That's nice. Uh, okay. What that allows us is basically to have the printf functionality.
I never understood fully. Maybe Mario can enlighten me. I never understood fully how to deal with arbitrary long strings coming from a user without doing some kind of buffering, and then if this buffer is not enough, do more buffering, then go with this.
Marinho?
Well, unfortunately, there's no easy answer to that. Um,
Oh, yeah.
the
Yeah, it
simplest
makes
way
sense.
is just the simplest way is to just say, okay, if you go beyond a certain size, I'm going to stop.
Fresh.
Like you gave me too much stuff, so
Yeah, sure.
deal with
But
it.
couldn't you use a
So,
stream? Like, isn't stream exactly for that type of purpose? That you
What
just
is a string?
are
like
you talking about a C++ stream? Because this is C. This is not C++.
uh, stream Haskell.
Oh, you're talking about a Haskell stream. That's even worse.
Yeah.
Yeah, I'm pretty sure. This is used for exactly what you wanted. You don't know the size, but you want to just keep
Yeah, but
getting the data.
in
Keep getting
C,
the data.
in C, what do you do? What should you do in that case?
How to do stream
I'm
Because
pretty
the
sure
problem is
the
this: I have a command line, and I want to give the user the power to write whatever he wants with no limits,
um,
no size
you
limits.
you could here's a possible solution to that. You could, if you have some kind of way to parse incrementally, um,
Mhm.
allocate a ring buffer, and then as the data becomes available, you parse it, and then you clear the data that you already parsed, and then
But it sounds
that's it.
like something that you have to be way smarter than just
Oh no, it's more
that, right?
work. It's definitely more work. That's for sure. Uh, but it's not that smart because, as far as I remember, there is some getting inputs from the user. Let's say that it's the keyboard that you don't depend on the new line. You can every single press of the user, you
Yes.
can just grab that and do what Marinho said. You can basically just append and keep appending and keep like probably that's very inefficient, but you keep
Appending to what?
to a
Actually,
dynamic array.
appending.
You
No, not a dynamic
you
array.
don't have dynamic arrays.
In
A
C
ring
you do.
buffer.
In C you do
Guys,
have
ring buffer. A ring
dynamic
buffer.
arrays.
A ring buffer is an array of fixed size that's
Yeah.
treated as a queue, essentially,
Mhm.
where you maintain two pointers to where the first element to be consumed is and the last element to be consumed is, and they can move kind of independently as long as they don't cross each other, and they can wrap
Mhm.
around the array from the end to the beginning as well. Um, this way, you have a queue where you can put some data in, consume some data, then take some data out, and then put some more data in, and so on. And as long as you don't completely fill it up, you can always have space to add more stuff. Like,
Oh, okay,
um,
okay, okay. So I think I got it. So my Juice question is, how do you do this? How do you do what Marinho just explained in an example without dynamic arrays, which means no implementation by yourself and no scanf?
ring buffer. A ring
Yeah.
buffer is a fixed size array, no dynamic array, no reallocations. You allocate the buffer once. You choose
Sure.
a reasonable size, not too small, not too large. And then you add data to the end of the ring buffer, and you take
It
it from
doesn't
the
sound
beginning.
right to me. Sorry. For example, take any terminal interpreter that we use every day. You can write really long command lines, and you just press enter and magic happens, right? The terminal interpreter receives this and do something with it.
No, but what Marinho is saying is the under the hood mechanism that would make the magic. That's what he's describing, right, Marinho?
Yeah, but a ring buffer, it's still something that you go and fill it, and you might overflow
No, no,
it.
no. But you're gonna pop out of things out of that, right, Marinho?
Yes, you will.
You will pop throughout the process of the user typing things down. The ring buffer will be doing some crazy, maybe not as crazy, but it will do some sort of transformations and mechanisms to pop data out of the ring before it
It's
gets
not
filled.
it's not crazy. You just bump a pointer essentially.
Yeah, pretty much. So, but that's again, it's very fancy. Maybe Mageta can later explain how he did it in his Lisp for us to see a different implementation. Um, but yeah, so in without dynamic arrays, without any sort of built-in magic, that's a lot of work. That's definitely a lot of work. Okay, but going back to our point. So what this is basically effectively doing, you are basically you now have a printf for yourself because you can add wrappers to this vanilla printf. So for instance, let's say that every single time you print an error, you want to actually have error column in your error message. You can put that built in the lvar error and just put what really matters. So I actually did the same for spatula. I made an error message function that would wrap the error message with some fancy things like the red color for the terminal. So it indicates that it's an error. You can do the same thing with this sort of thing. But of course, his thing is a little bit better than mine because his thing he actually accepts a variadic number of arguments, so he can actually put the formatting in here. I had to make the formatting myself before calling the error function, which
Can
is
I just say that
nice and
that
cool.
I don't like variadic arguments
Yeah, you said
at
that
all?
maybe 20 times since I
Everybody
I
said
met
that.
you. No, no, no. But Marinho disliked that to a degree that is not comparable with you.
Well, all right. Okay.
Uh, okay.
Like if you need an arbitrary number of arguments, just use a list or an array or whatever.
Yeah, I guess that makes sense. He also wants to use this mechanism for his lassert macro. So apparently the way that you do that in C, you put the three dots in the macro, and then if you want to
Mhm.
pass that variadic number of things further, you just put the hashtag
Yes.
hashtag in this variable here.
That's
Uh,
so terrible.
there are at least three hidden environment global variables that you should be aware of. This and the one to provide the line number and the column number. Those are very useful.
Um,
Those are
the
very, very
line and
useful.
column number are more like dynamic binding, I think, right?
Yeah, but it's basically the same thing. It's a magic name in caps that you need to be aware.
No, but the problem is this stands out so much from the surrounding code. It's like, and it's worse because it's inside of a macro, a string-based macro. So like,
Yeah.
ah,
But maybe you're not understanding. He's trying to do some machinery in C to use to generate better messages
No,
from
no,
his
no. He
interpreter.
understood that.
It's
Marinho
not something
100%.
to
Yeah,
use
yeah.
to
You
miss.
will never see this, but the developer of the language, Marinho said that he would be.
Ah, okay.
It's unpleasant to look at. That's what he said.
Oh, well, definitely is.
And then here's an example of the same trick. And again, this macro is actually using the val error, which basically means that it's calling this. So it basically means that it's doing the printf machinery. And anyway, the macro. What else do we need to fix? We are close to the end. Oh yeah, now we can actually have proper natural language descriptions of the enum. Now it makes sense because we have a mechanism to pass it easily. So we're gonna just do a switch with the enum and return the string, the proper readable, human readable in English string of it. The only thing that I really dislike is this like like you need to call this function twice and it adds a little bit of noise, which I don't like, but that's fine, I guess. And here's the example. Here's the final example. So function plus passed incorrect typo for argument 1, got q expression expected number, which is really good, really
correct.
really great error messages. Function had passed incorrect number of arguments, got two expected 1. So now the reporting errors is a lot nicer. And that's about it for variables. So now you can do defines in the Lisp in the REPL, and you can have an environment, and it's immutable. Again, I need to emphasize this because I was so certain that it would be like let's have a global environment in like somewhere, and let's mutate that every single time. And the author decided to go straight up with immutable design. That's like props to the author. Props to the author. The only thing that sucks is that you need to do the deletion and you need to remember you don't have defer, so you're gonna have to do that a few times, and you're gonna have to remember to do that. And that's it. So next time we're gonna talk about probably user-defined functions. User-defined functions. So where is the? Okay, so it's gonna use Haskell syntax. It's gonna use Haskell syntax for the lambda.
Which is possible because backslash is a valid identifier. It's a valid symbol in our language.
Yeah, you don't have to write
It's
it down
not.
fn or lambda. You can just use the backslash. Uh, and this will probably increase the
Oh,
lval.
I just realized something.
Holy
It
balls.
doesn't
But
allow arbitrary Unicode in symbols.
Oh, it doesn't. It
oh
doesn't
no,
allow arbitrary Unicode.
no, it
Our
doesn't.
language does.
No.
Our language does. Uh, but look at
I
this, man. This
mean,
struct is getting so bloated. Like it's literally something to do everything. Everything is an LFL, which means that everything needs to have everything because you don't have ADTs, you don't have you need to have the declarations of things that don't matter. Doesn't matter for like a
Yeah,
function.
come on. There are better ways to do this in C using yeah
That sucks.
enums and stuff. But yeah, but I understand it for simplicity.
Yeah, no, it is for simplicity, but holy moly, man. And that's the thing. That's not an uncommon design. Like if you I don't know if you watch any of the most recent Musalizer videos from Zozin, he has one of these, but gigantic,
Holy
like very
shit!
very big, with everything that you
terrible.
may like widgets, sounds, the logic. There's a
It's
bunch of stuff in there.
one structure to win them all, right?
Yeah, he calls it
Like,
the plugin because he has
like,
hot reload in his program because he's a Chad.
Mm-hmm.
Uh,
like, I don't see a problem with that if you are using all the fields. But that's not the case here.
No, but that's the thing. In his particular case, he's going to use some of the fields at some parts of the process of the pipeline, and he's going to use some other parts of the struct in some other parts of the pipeline. But it's basically the state monad. It's literally the state monad at that point. This it's worse because sometimes in a single pipeline you're not going to use some of these fields ever.
Mm-hmm.
Because it's a function, so it doesn't make sense to have whatever. Um, which is again, it's C. I need to remember myself. This thing is C. It's fine. It's fine.
No, it's not. It's not.
It should be
Come
fine.
on, we can do better than this. Don't be content with mediocrity.
No, that's my deal. I'm also not content, but I need to remember that a lot of the internet was built using this
Oh,
level
definitely.
of the
I
abstraction.
believe, Lemos, I believe a lot of internet infrastructure is still built like this. I would not be surprised. I would not be surprised.
I'm gonna finish the recording now.